Hi, welcome back to Chem 2B, Chapter 12 this time. This is going to be a short, quick intro into Chapter 12, talking about waves and light. So this chapter is about quantum mechanics, basically, and it's talking about how light is neither a wave nor a particle, but have properties of both. But what is a wave, basically? You all know what it is. A wave looks something like that. And in this is the wavelength. And the frequency is the number of times that this happens. So from here to here, would say that's 1, because the wave happened 1 time. And then that's 2. So that this wave would have a frequency of about 2.5, kind of. So that's what a frequency is. And in this class, they're going to use the symbols of lambda as wavelength and nu as the frequency. And the units that these use, wavelength uses, it's a length, so it uses meters, and other units that correlate with meters, like the nanometers that are related to meters, and frequency is measured in 1/second. So second to the -1, but the unit that is used regularly it's called hertz. But it's basically 1/seconds. And the reason why it's 1/seconds is because there's an equation that contains these two where it's the speed of light, c, is equal to the wavelength times the frequency, and the units for c is m/s, meters per second speed, and that's because it's meters times 1/second, and that's what it gives. And c, which stands for the speed of light, is approximately 2.99. It's a bunch of numbers times 10 to the 8, but you can round it off and use 3.0 times 10 to the 8 meters per second. These units and this equation is usually interchangeable, so the c is constant, it's always going to be this. But for a problem, they can give you either the wavelength or the frequency and ask you to find the other based off one. And an example of such problem is this. So right here, they ask you to calculate the wavelength. So if you're looking for this and you know the units are going to be in meters and you're given hertz, which, like I mentioned earlier, is 1/second. And that's the nu, which is the frequency. And the equation again is c is equal to lambda times nu. We already know c, it's even said right here too, and we're looking for this, the wavelength. So the wavelength is going to be, if we divide both sides by nu, you get the wavelength isolated. So the wavelength is going to be c over nu, and you just plug it in. The wavelength is equal to 3.0 times 10 to the 8 divided by 7.2 times 10 to the 14. And we know the units cancel out, so we don't have to include it, but to be safe, you can do meters per second divided by 1/second is to meters per second times second over 1. It cancels out and you're supposed to be left with meters. When you divide these two numbers, you get 4.1, around 1.7, I'll round it up, times 10 to the -7 meters. And if you go back to the question, usually they do this a lot where instead of just leaving the answers in meters, they ask you to put what units they want the answer in. And right here, they're asking for nanometers. And for this kind of questions, there are usually charts that the professor would provide, like before the class or during the class, that tells you, oh, these are units that you're kind of supposed to know. but the most important ones include nanometers, because that's the unit that they use for visible. That's the visible light units is usually done in hundreds of nanometers, because the visible light ranges from 400 to 700 nanometers. So that's going to come up a lot. And also micrometers, I've seen that too, and picometers. These are the three most used units that you're going to have to just associate 10 to the negative 6 with micro, 10 to the negative 9 with nano, and 10 to the negative 12 with pico. So when they're asking for the units in nanometers, you have it in meters here. So to change meters to nanometers, since nanometers is smaller than meters, you multiply meters times 10 to the positive 9 instead of negative 9. And you get that in nanometers. So right here, we just do 4.17 times 10 to the negative 7 times 10 to the negative 9. And it's 9 minus simple math, quick math, 9 minus 7. That means it's times 10 to the second power, which is just going to move the decimal point 1, 2 ways, right? So it becomes approximately 417 nanometers. That could be your final answer. This answer helps us answer the other question I already mentioned about how this is within the 400 to 700 visible wavelength area, and that falls in between. So the answer is going to be visible. And I'm not exactly sure if you're supposed to memorize the area that these fall under, the wavelengths these fall under, but sometimes they might give you a chart. It'd look something like this. Then write, like, let's say 10 to the negative 9, then 10 to the negative 7 meters, and then say this falls under like radio or something. I'm not saying it does, but that's the way to answer this question. You get the answer here, then you put it back in meters, and this is the answer in meters, and then it'd be like, oh, this is around 10 to the 7th, which falls into visible wavelength, and then you answer the question. And that's how you answer questions like these.